August 1945, the United States of America conducted the two most devastating attacks in modern warfare. They left over 200,000 dead in more than 2 to 4 months. What did this? How did they manage to kill nearly 250,000 people? What happened was a reaction on the nanoscopic level, a reaction that involved atoms. What's an atom? Atoms are the most basic building block making up our universe. The atom is part of everything. Anything you touch is made up of millions of atoms. In fact, it is estimated that it takes 100 billion atoms to make up the head of a pin. But atoms don't just exist in the things we see, touch, and feel. They also exist in the air and gas we breathe or get rid of. Even a single fart contains 200 billion atoms. But what do these atoms consist of? In this atom, there exists a dense center which contains subatomic particles. This dense center is known as a nucleus. Although it accounts for 99.9% of the atom's mass, it takes up about 1/100,000th of the atom's volume. That's about the size of a marble in a baseball field. This nucleus has protons, positively charged subatomic particles, as well as neutrons, which have no charge. Therefore, it seems natural to think that the atom must be positive. Around the nucleus, there does exist a third subatomic particle, the electron, the negative particle in the atom. The electron occupies a space around the nucleus and moves in it continuously. Electrons are responsible for the atom's properties, whether they be chemical or physical. Different elements have different atoms, with different numbers of electrons, protons, and neutrons. The discovery of the atom did not just come to us. It took many scientists and many years to be able to come to this immensely accepted and understood idea of the atom. The atom started off with the Greeks. The ancient Greeks thought there must be some tiny indestructible thing making up everything. They believed atoms were solid and varied in size, shape, and weight. The Greeks put us on the right track. Many years later, an English chemist named John Dalton first put the perspective of the atom out there. John Dalton made 5 points with regards to atoms, which have laid the foundations of atoms as we see them today. Dalton stated that all matter is made of atoms. Atoms of the same element are identical. Atoms of different elements are different. Atoms can combine to form compounds, and those atoms can neither be created nor destroyed. Dalton was also able to calculate relative atomic weights of the atoms. Some 89 years later, J.J. Thomson discovered the electron with the idea of protons already existent from before. J.J. Thomson picked an atom with a sea of electrons and protons. This came to be known as the plum pudding model. At this early stage, scientists began to take sides on the idea of the atom, with scientists such as Ludwig Boltzmann firmly defending the idea of the atom, and scientists such as Mach firmly criticizing it with the argument that such a tiny thing could not be pictured. Around this time, Max Planck came to a great discovery. Planck discovered that energy could be quantized. This means that energy was not just one continuous spectrum as had been thought before. This would later be of a large significance when depicting later models of the atom. Then came Einstein. In 1905, Albert Einstein wrote a paper on Brownian motion, which provided the first solid evidence for the atom's existence. In 1910, Ernest Rutherford worked on honing the picture of the atom. Ernest Rutherford would state that the electrons were not mixed with the protons, but rather surrounded the nucleus, and that between the nucleus and electrons, nothing but free space existed. Then came the idea of the neutron, the neutral subatomic particle which resides along the protons within the nucleus. In 1932, James Chadwick proved that this subatomic particle was present and accounted for almost half of the atom's mass. Niels Bohr's model of the atom is the most commonly seen model in the eyes of the general public. Niels Bohr describes the electron circulating around the nucleus in orbitals. Each orbital has a specific energy, and extra energy is needed to excite an electron, or to make it move to a higher energy level. While that standard is an oversimplification of the atom, it gives a good description. But after all this, some problems still persisted. First of all, if electrons roamed around the nucleus and were negatively charged, why didn't they crash into the positively charged nucleus? Because of their opposite charges, they should attract. A solution to this was proposed by Heisenberg. Heisenberg created the uncertainty principle of quantum mechanics, and by describing electrons as particles that act as waves, they could not crash into the nucleus. What about the protons? Why did the protons not repel each other, breaking the nucleus? The answer to this came with the understanding of a force called the strong nuclear force. This force was much stronger than the electromagnetic force responsible for causing repulsion. As it currently stands, we only know so much about the atom. While we cannot be 100% sure of anything we know about it, we observe every day to better understand this magnificent thing that exists everywhere and is responsible for everything that happens.
Here's my key, philosophy. A freak like me just needs infinity. Relax, take your time. And take your time to trust in me, and you will find